Very good morning. Today we are going to see a problem on DC series motor. Take down this problem. A 6-pole lab connected DC series motor with 864 conductors takes a current of 110 amperes at 480 volts. The armature resistance and the series field resistance are 0.18 ohms and 0.02 ohms. The flux per pole is 50 milliwebers. Solve for the speed. This is the problem given. See, previously we have seen the DC generators. In DC generators, that is generated here. But DC motors, it is vacuum. Okay. So, what are all the given things? First, poles is given. Poles P is equal to 6. And the conductors are given. That is Z is equal to 864 conductors. And the voltage, terminal voltage is given, that is 480 volts, and the current takes the current of 110 amperes. So takes the current of 110 amperes means that is the load current. Load current also given, that is 110 amperes. So in series motor, load current is equal to armature current. Okay, then armature resistance is given. Armature resistance is given as 0.18 ohms, and the series resistance is given, that is 0.02 ohms. Next, the flux per pole is given, that is 50 milliwebers. So we need to find out the speed. So first we need to frame the diagram. Okay, connection diagram. So this is the DC motor. So M underscore means DC motor. So in that series motor, so series winding will be there. Okay, so instead of shunt winding, series winding will be there. So inside this motor, the armature winding will be there. So that armature is the rotating part. Okay, so next this field is connected in the series. Okay, so next IA. So the motor 480 volts is given. So positive terminal, negative terminal. So terminal voltage is 480 volts. So load current is given. Load current is given as 110 amperes. So here series current ISC is there and IA also there. So here in series connected motor, IA is equal to IN. Next, lab connected winding is given in the question itself. So for the lab connected winding, A is equal to P. So A is equal to 6. Okay. Next, we need to find out the speed. So back EMF, what is the formula for back EMF? So back EMF is equal to V minus IA into RA plus RS. Okay, so V is terminal voltage 480 minus IA. So IA is given in the problem 110. So 110 into RA plus RC. RA is given in the problem is 0.18 ohms. Next RC is given in the problem is 0.02 ohms. So if you simplify this, we will get the back EMF. Next, back EMF formula with respect to poles, flux, and armature conductors and A number of parallel paths. So that is EB is equal to P phi Zn divided by 60A. Now we need to find out the speed. So if we take out the speed here, then this formula can be rewritten as 60A into EB divided by P phi Zn. Now you know all the things 60. So A is 6, EB is 458 volts. Already we calculated, and volts P is 6. Next phi is 0.05 webers. Next Z is given in the problem as 864 number of conductors. Next we need to find out. So if you simplify, we'll easily get the speed. That is 636 rpm. So the speed of the DC series motor N is equal to 636 rpm. This is the answer for this particular problem.